All right. So we're taking a look at this warm-up problem. It says a student is shown the velocity versus time graph for two objects and asked to decide which one is moving faster. Okay? The student responds, well, B is faster because it has a steeper slope. Your job, my friends, is to tell me what, if anything, is wrong with the student's statement. If something's wrong, explain the error and how to correct it. If it's correct, tell me why. So before I ask for answers, I want to let you know that I love this kind of question. I want to let you know that this is the kind of question that allows me to tell if you really get something. Because not only are you looking at the graph, but you're looking at another person's opinion that's got an opinion and a reason. And you have to decide not only whether they're right or wrong, but why. Like, what are they thinking? Or, yeah, for sure. Okay? So, I'm going to take a poll real quick. Raise your hand for me first. Do you think that the student is right, that B is faster because it has a steeper slope? Hands in the air. Raise your hand if you think, no, the student is wrong. Okay, and you can put your hands down. I see that some people did not yet vote, and that's okay. Okay? I'm not going to call you out and be like, what's your problem? No. Like, it's all good. But I want you to be thinking about it and not turning your brains off saying, I don't do this. Like, yes, you do. Yes, you can. We're going to go through this. So I saw a lot of people that said, no, that student is wrong. So help me out. What's wrong? Let's start back in the back.
A has a higher velocity, even though the slope isn't steep. It starts higher on the graph, and B never get to that rate.
Okay, so I heard a lot of things that you said, and I just want to make sure that I'm understanding them. So you said that A has a higher velocity because it's higher on the graph. Is that what you said? Yeah. And what is the graph measuring?
Velocity over time.
It's measuring velocity. So that makes sense to me. You're saying that it's measuring velocity. Oh, frozen. Bam, there we go. Is that better? Now you can just see my pretty yellow picture. Okay. Which means that at any given time, if I look at any given time, the value for A is higher than the value for B. Is that kind of what you were saying? Okay, Ad, what do you want to add?
So the student failed to realize that the graph is a velocity versus time graph and not a position versus time graph. A is going faster as it has a higher position and velocity, but B has a greater acceleration as its slope is indeed steeper.
Whoa! Did you guys catch what she just said? That was amazing, right? That was good. Now, let's think about what just happened here. That was a thorough answer. Would you agree? Yeah. So not only are we acknowledging, thank you, that not only are we acknowledging that the student was not quite right, but figuring out what that student might have been thinking. That was the thing that I was just about to ask. Was I could totally see if I asked this question, if I gave you a graph like that on a test, and I asked you which one was moving faster, I would guess that some non-zero percentage of you would say that B is going faster. Because you're looking at the slope. What kind of graph do you look at if the slope is bigger and that says it's going faster? A position or a distance over time graph? Does that make sense? Looking back at the reference sheet that we made yesterday, just a friendly reminder, this is where I would find this information. Remember we said that for a position graph, if it has a slant, if it has a slope that's not zero, then we know that the steepness of the slope indicates the velocity, right? So if I had given you this picture, come back, and I had changed the velocity to a position, then that student would be right. But because it's a velocity graph, that means that we just have to look at the numbers, just have to look at the values to tell us which one's going faster. So that's one piece of it. And then there was another thing that you added. You added so much that was so cool. Like, she just did all of what I needed. And what was the other piece? What is that it's bigger? What did you just say? Acceleration. So that's one piece, is that if it's a position versus time graph, then it would be going faster. The slope of this graph does indicate the acceleration of the objects. Would you agree? Really quickly for me, my extra little follow-up here would be that if I now draw an acceleration versus time graph, okay, and I'm going to go ahead and put A right here, okay, that's object A, and its acceleration is right there. Talk to your table mates. If you were going to graph the acceleration of object B on the same graph, where would it go? Talk right now. Where's it going to go? Above, at the same, below, at zero? I don't know. You tell me. Is that it already? Is it? Oh, okay. Freaking me out. All right. Thanks, friend.
I do too.
All right. Did you come up with an answer? What did you guys say? Above, at the same, below, at zero? Above. Why?
Because he is like getting faster, like more faster, quicker than
Yeah. It's getting faster, right? It's getting faster. So B has a higher, what? Acceleration, even though at all the points on this graph, B is moving slower. If we extended this graph out, because, I don't know, why not? If we extended this graph out and we made time go even longer, what's eventually going to happen to the speeds? A and B would cross. And now B would be going faster than A. Is that okay? How are we doing with this thinking process? Is that okay? Fantastic. All right, cool. All right, we are going to do another activity in just a moment here. Before we do that, though, I want to draw your attention to a couple of quick things. So we're going to do a graph matching thing. I don't think we're going to get to the quantitative data analysis today. That was the green sheet. I gave you this yesterday, right? Okay, if you did not yet do it, either you didn't know you needed to or you just didn't get around to it, this is your homework for tomorrow, so make sure that when you come in tomorrow, it's done. If you need another one, then come get one so that you have it, okay? Right now, we're going to do a quick activity, and it's going to go fast. So let me get you ready for it. Let me get you set. We are going to divide ourselves